This is a walkthrough of Thursday's Physics 131 practice exam from September 9th, 2021. Problem 1. A motorcycle travels along a straight road at constant speed for 10 seconds and then uniformly slows to a stop over the next 10 seconds. The distance traveled over the 20 seconds is plotted here. What is the deceleration of the motorcycle over the 10 seconds from 10 to 20 when it's slowing down? So constant speed here, slowing down to a stop. Part B, what's the slope of that line? The tangent line at 16 seconds. So for part A, from 0 to 10 seconds, we can easily see that the speed is 250 meters in 10 seconds, which is 25 meters per second. It goes 25 meters every second. So constant speed over the first 10 seconds of 25 meters per second, then it slows to a stop uniformly over 10 seconds. If it starts at 25, slows to a stop uniformly over 10 seconds, the deceleration must be 2.5 meters per second every second. That's part A. Part B, we have to get the slope of this line. Slope is the rise over the run. It looks like the rise goes from 200 to 400. So that's 200 meters. The run is like the entire graph, which is 20 seconds. So 200 meters over 20 seconds. 200 divided by 20 is 10. The units are meters per second. And this happens to be, of course, the speed of the motorcycle at 16 seconds. If it starts at 25 and you subtract 2.5 meters per second every second for 6 seconds, you have to subtract 15 meters per second. So if you start at 25, you subtract 15, you're down to 10 meters per second. That's the speed of the motorcycle right there. That's problem 1. Problem 2, there's a motorcycle 15 meters from the end of a 100-meter bridge, enjoying the view. The bridge is narrow, only has room for one train. A horn honks. The motorcycle's got to get off the bridge as fast as he can. He can accelerate at 10 meters per second every second. The train's going 50 meters per second. He starts when the train is 100 meters away. Will the cyclist avoid the train if he heads toward it? Part B, will the cyclist avoid the train if he heads away from it? If the motorcycle heads toward the train, he'll have to get off the bridge before the train gets to this end of the bridge, before the train travels 100 meters. The train is going 50 meters every second. That's going to take 2 seconds for the train to get there. So the question we have now is, how far can the motorcycle get accelerating from rest at 10 meters per second every second in 2 seconds? He's got 2 seconds to beat the train. Well, there's an equation for that. X is 1/2 AT squared plus VIT, starting at rest, enjoying the view. X is 1/2 AT squared. 4 times 10 is 40 times 1/2 is 20 meters. He's going to make it. He only has to go 15 meters. He's got room to spare. Now let's look the other way. He's going away from the train. And so now the train has to go 200 meters to catch up to the motorcycle. The motorcycle's got to go 85 meters. The train has to go 200 meters. He has 4 seconds because the train is going at a constant speed of 50 meters per second. He starts off the train's constant speed of 50 meters per second. He's accelerating 10 meters per second each second. We can use the same equation, 1/2 AT squared. T squared is 16 times 10 is 160 times 1/2 is 80. He's still going to be on the bridge. He's got to go 85 meters. Almost. So he makes it by 5 meters if he goes towards the train, doesn't make it by 5 meters if he goes away from the train. On to problem 3. We have 2 archers here. At t equals 0, an expert archer shoots an arrow at a speed of 40 meters per second at an angle of 53.13 degrees above the horizontal at a target some distance away. It's the same height as the arrow is released. The second archer, also an expert, is 50 meters ahead of the first archer. She shoots an arrow 4 seconds after the first archer releases his arrow. The arrows hit the bullseye simultaneously. Part A is, what time t does the first arrow pass over the head of the second archer? Part B, what was the initial velocity of the second arrow? Okay, C and D are graphs. We'll address those later. We have a good diagram. First thing we got to do before we do any physics is to get that initial velocity of the first arrow into x and y components. So v initial x is 40 meters per second. Cosine 53.13, that's 24 meters per second. Let's put that on the diagram, and let's think about what this means. Every time you calculate something, think about what it means. 24 meters every second is a constant speed in the x direction. 1 second is 24 meters, 2 seconds it's 48 meters, 3 seconds it's 72 meters, etc. Every second it goes 24 meters. The y direction, we have 40 meters per second, sine 53.13, when that's 32 meters per second. Let's put that in the diagram. What happens to this? Well, gravity takes away 10 meters per second every second. After 1 second, it's going 22 meters per second. After 2 seconds, it's going 12. It's going to take gravity 3.2 seconds to take away all that speed. 3.2 seconds to reach the peak, 3.2 seconds to come back down and hit the target. The total time of flight for this arrow is 6.4 seconds. Okay, to answer part A, we just have to calculate how long it takes an arrow that's going 24 meters per second horizontally to go 50 meters. It's 50 meters divided by 24 meters every second, which is 2.08 seconds. That's part A. Now for the hard part, part B. What's the initial speed of the second arrow? Speed and direction. All we have to do is be careful and think. There's no really hard steps, but there's a bunch of them. We know the second arrow is released 4 seconds after the first arrow. The total time of the flight of the first arrow is 6.4 seconds, 3.2 up, 3.2 down. We know the first arrow is going 24 meters every second horizontally. And we know it's in the air for 6.4 seconds. We can calculate how far away the target is. 6.4 seconds, 24 meters every second. It's 153.6 meters. So the distance from the first archer to the target, 153.6 meters. If the arrow hits the target at the same time, and the second arrow is released 4 seconds after the first arrow, the time of flight of the second arrow must be 2.4 seconds. How far does the second arrow have to go horizontally? Well, it's 153.6 minus 50 meters. 50 meters shorter. It's got to go 103.6 meters in 2.4 seconds. The initial x for the second arrow is 43.17 meters per second. Now we have to address the vertical situation. To get v initial y for the second arrow, all we have to do is realize the time of flight of this arrow is 2.4 seconds. If the time of flight is 2.4 seconds, and it's going to land at the same place it started, vertically, y is 0, it's got to be 1.2 seconds up, 1.2 seconds back down. If it's going to reach the peak in 1.2 seconds, the initial vertical speed must have been 12 meters per second. It takes gravity 1 second to knock off 10 meters. It takes 1.2 seconds to knock off 12 meters per second. So we have both components of the initial speed of the second arrow. So the initial speed of the arrow is 44.8 meters per second, and we can get the angle at which it was shot with the arctangent function. There's v initial y, v initial x. Theta is arctangent of that, 15.5 degrees. So the answer to part C, 44.8 meters per second at 15.5 degrees above the horizontal. Ooh, that's part B. Now we can address the graphs, which are C and D. If we're going to get the trajectory, we should get the heights. What are the maximum heights? So the first arrow has an initial vertical speed of 32 meters per second. It stops at the peak. On the way up, it averages 16 meters per second upwards. The time for the upward flight is 3.2 seconds. The maximum height is just 16 meters per second times 3.2 seconds, 51.2 meters. The second arrow has an initial vertical speed of only 12 meters per second, so it averages 6 meters per second on the way up. The time for the upward flight is 1.2 seconds. So the maximum height is only 7.2 meters. Remember, the second arrow is shot at a low trajectory, 15 degrees, and a lot faster. First arrow shot at 53.13 degrees. We can now coplot the heights. There it is. We can see what's going on here at 3.2 seconds. The first arrow reaches the peak, and the peak is 51 meters about. Makes sense. This second arrow's released at 4 seconds, reaches a peak after 1.2 seconds, which is 5.2 seconds, and the peak is about 7.2 meters, and they hit the target. They get back to the ground at exactly the same time, which was specified, at 6.4 seconds. For horizontally, speeds are constant. These are going to be straight lines. The first arrow is 24 meters per second the whole time for 6.4 seconds. The second arrow stays at 50, starts 50 meters ahead, and then at 4 seconds it goes up, but it goes up at a higher slope, 43.17 meters per second, and they get to 153.6 simultaneously at 6.4 seconds, so somewhere up here. There it is. The blue line is the first arrow. The slope is 24 meters per second. The orange line, constant at 50, arrows released, slope is 43.17 meters per second, and they meet at the target. Note this spot right here, this is where the first arrow went over the head of the second arrow, and that is 2.08 seconds as we calculated in Part A. That's Thursday's practice exam for 9/9/2021.